talked about the integrals in an iterated integral determines an area of the region of integration. So what if we carry out the computation? We just compute this iterated integral with integrand equal to 1. So the number that you get means the area of the region. Okay, so let's look at these two I would say examples. Okay, if I have a region described by these inequalities, so let's look at what this means again, just for practice. So horizontal direction is x direction, vertical direction is y direction. All right, and y is bounded between g1 of x and g2 of x. That means I have y equal to g2 of x, that's larger, y equal to g1 of x, that is smaller. Okay, so for each x value, I'm gonna have an associated lower bound sitting at g1 of x, and I integrate with respect to y all the way to the point when y hits g2 of x. Okay, but I don't want to look at any arbitrary x value. I only want the part where x is in between a and b. So I only want the part that's within this strip. So this is the region R. When I do this, when I carry out this computation, the value I get is the area of R. Okay, and here we want to pay attention to the order of integration. So here I have one variable bounded by two functions, and the other variable bounded by two constants. Okay, so I always want to write the one that's bounded by constants only outside, and the other one inside. Okay, so I would not say, oh, the area is g1 of x to g2 of x with respect to y, and a to b with respect to x. So this is wrong. Okay, we always write the one that's bounded by constants only outside, not the other way around. The order is important. Okay, now we have the other situation. Okay, so as opposed to x being bounded by two constants, I now have y bounded by two constants. In this case, you're going to have x bounded by two functions of y. Some of them can be constants, or both of them can be constants. If they're both real constants, then the region you have will just be a rectangular region. Okay, but we want to look at more general case. So let's just say x is bounded by two functions of y. All right. So if we look at this, what this says is, all right, now along the x direction, I have a curve x equal to h1 of x. Sorry, h1 of y. Oh, and I have another curve x equal to h2 of y. Okay, and for any given y value, I only want to have the x from the lower bound, which is this curve, now x direction, horizontal direction, to here the upper bound of x. So for a different value y, you would have a different lower bound and upper bound in general. All right, but I want to restrict my y between like C and D. So I don't care about other parts. I only want the part of y from C to D. So this now is the region that we have. Okay, region of integration. And the same rule applies. The variable that's bounded by constants only, I leave it outside. The variable bounded by functions, I put it inside. Okay, do not switch the order. So this is how the formula for finding area of a region.